So as we're looking at scatter plots and you look at the line, and you're like, well, wait a minute. My line's not going through all the dots. Like, I see random dots all over and they're not in the line. What's up with that? When you're finding a good equation for a scatter plot, you're not going to go through every single point. Okay? These aren't linear in that they go through every point like we're used to. What we're going to deal with here is we're going to start figuring out a way to make the best line or the best equation possible that it's going to be in the middle of all of our data. So sometimes you're going to have dots and you're going to have to draw a line. This time it was done for us. The best represents the data, but I do want to make a note on this because it'll help when we get to some of the ones you're doing. If you can find a way to get equal dots on both sides of your line, you're probably going to be really, really accurate. You're like, okay, so what do you mean? Like here, for instance, if I look on top of my line, I see 1, 2, 3 random roaming dots. Underneath my line at the bottom, I see 1, 2, 3 random roaming dots. Go to your regular seat. I'm not going to have you two just gabbing the whole hour. So, that's what we mean when we're trying to find a draw line that represents the data. There's actually a way the calculator can do this for us too. And that's something we're going to take a look at tomorrow. So, we're going to pick 2 points on the line and find their slope. So let me give one more bit of advice. When you're trying to draw your line, you do want to make sure it goes through at least 2 points, preferably ones that have whole numbers, is what we're going to be looking for here. So here, my line went through those 2 particular points, and so why do I care about that? Because I need to find the slope. So quick reminder here. Here's my slope formula. And so if I've got these 2 points, 5, 10, and 6, 8, I've got my x1, y1, my x2, y2. In my formula, I'm directly going to be substituting. And even if I'd have had these points the opposite way, this would still work. y2 minus y1, x2 minus x1, and I go ahead. I can do this in my calculator too if I feel more comfortable with that. And I always look to reduce, and I'm like, well, that doesn't really reduce. It's like this. Either one of those would work. Okay, -2/1 or just plain old -2. If I do -2 divided by 1 in my calculator, we kind of know what we're going to. Ooh, that's funky. We're going to get -2. So I've got my m. Find the y-intercept. Okay. Here's my y-axis. Y-intercept, remember, is my b value. And so then once I've found my slope and my y-intercept, and I plug them in, y equals m x plus b. It's a whole lot easier to learn this if you don't have stuff squawking in your ear. Just a suggestion. Again. And that's it. Or if you put -2/1, that'd be fine. So that's kind of what we're going to be working through here is we're basically just trying to find the equation of a line. We find the two values, we're done. And that's the main focus of today. What's that? Because here's the y-axis, so I'm just going to follow until I see the line run into it. And it happened to run in at 20 up there. So what we're going to do now, I'm going to keep this handy. Is we're going to get onto this first page of our packet here. And so the only difference between the problems we have here and the ones that we had in the example was we're going to plot the points and we're going to draw the line. But there's good tricks to this. So my x and y axes are labeled. So here's all my x's. Here's all my y's. And we're just going to start plotting these. So x is 0. Y is 22. Get that first point in. X is 1. Y is 22 and a half. So we got to go in the middle here. But that's all right. X is 2. Y is 23 and a half. X is 3. And we're just going to keep working our way along. Again, this isn't linear. It's not going to give us a perfect line for all of these. Oops. And apologies to those in the video that I keep interrupting, but I'm going to do one more thing. If I can hear the music from here, it's too loud. It's distracting for people around you. So turn it down or take it off. That is the two options right now. If I have to get up and come find it, we're going to have an issue. Okay. So as you can see, you're like, kind of lopsided. It'd be kind of squiggly if I was going through here. So how am I going to draw a line through here that best represents the data? So if you've got something, the side of your notes or something, I'm going to kind of just mess with this a bit. And I'm going to be like, all right, let's see. And I'm also kind of looking out for the places where they're going through whole numbers. I'll be honest. I'm fudging it a little bit because I'm going, is that the best? Maybe. Is that better? No, not really. So here's what I'm going to do. I think if I draw my line and it goes through those 2 points, that is going to be the most accurate I can be here. So let's see. So I went through a few points. I had a couple down here below, but that's pretty close. This is more of a science than it is an exact, way of doing things. So now, to make my equation, I've got to find my slope and my y-intercept. So, my slope, if I went through a couple of whole numbers, like we chose to with these two, okay, still we're accurate. Here maybe is my x2 and my x1 and my y2 and my y1. And is it possible some of you get different equations for this? It is. So y2 minus y1 over x2 minus x1. As long as you're showing the process as you go along, okay, you'll never get yourself in trouble with one of these. So my slope is 1. My y-intercept, my b, again, I just go on the y-axis until I see a point where my graph crossed it. In this case, that's at 22. So when I go to make my equation for my best fit line, y equals mx plus b. And like I said, some of you, depending on the 2 points that you choose or go through, may have a little bit different looking of an answer. Like if you chose to use this point instead of this one, it'd be a little bit different depending on where you're at. So use the equation, ooh, we get to keep going, to predict the length of the baby alligator next September. You're like, okay, well, wait a minute. Here's this September. So let's see, September, October, November, December, January, February, March, April. So 8 would be May. 9 would be June. What are we looking for? September. 10 would be July. 11 would be August. You're like, oh my gosh, we're almost there. 12 would be September. So now you're like, well, wait a minute though. My graph doesn't go all the way out to that. So what am I going to do? Here's what we're going to do. We just figured out the month for September next year that x would equal 12. I have an equation that has x in it. So I'm going to replace the x with the number of that month next year, 12. And I'm just going to punch that in my calculator. And it looks like the baby alligator would be about 34 inches long by then. That's how I can use my line of best fit equation to get other information that I need when I'm doing this. And we're set with that. So with any of these, that would be how it would work. I'd plot the points, I'd find a couple that I think would work well, and I'd do it. I'm just looking to see real quick. I got one other one I want to do here. I think we should just rock out. Should we rock out the first two? I'm wondering if we should. Yo! Here? Yeah. Y-intercept. That's just me shortening it up. Yeah. Yeah, that's just me shortening that up a little bit. So, okay, let's play one more. Because again, I know this is kind of new and it's kind of weird. But I think once you see a couple, we're going to be okay here. Okay, one more together, and then we'll see what the ones in the back look like. We got a table again. X is on top. Y is on the bottom. So we got a graph first, so let's do that. So let's see, 0, and here's my x's, here's my y's, 327, hello. A little under 330. 306, all right, a little less than 310. 299, it's about halfway in between. 270, okay, there's a whole number 1. 254, little above there. 232, a little above 230. 215. 197. So I'm kind of looking, and I'm like, okay. Now, the nice thing this time is all the numbers are whole numbers here. So I don't have to kind of try to fix this to what I want it to be. I can actually make it work pretty well. Man, those all look pretty well aligned. Let's do that. So we've got to make sure we go through there. That's pretty good. I mean, we got 1 point that's a little off, but otherwise, we're getting most of the points in there, and that's always the job here. So if that's true, to be honest, I can pick. Let's see. we're going straight through there. So let's use this one. And it looks like we're going straight through there. So let's use 3,270. Again, any of them that your line is going through, you can use. Those just look like the easiest ones to me. So x2, x1, y1, y2. And we're going to do our thing just like we did on the last one. So my slope, again, we always start with the y's on top. So y2 minus y1. You can pick any 2 points that your line goes through. This time it's a lot of them. I just happened to see like, okay, that one is where my line started, so I used it. And then I saw the next one where my line was going directly through the point was this one at 3,270, so that's why I used that one. If I'd have used one of these other ones down here, I'd have been okay too. And then x2 minus x1. So let's see here. 270 minus 327 is negative 57 over 3, which is negative 19. So my m, my slope, is negative 19. My y-intercept, my b, is 327. That's always going to be when x equals 0. So if you see an x equals 0 somewhere, that's going to tell you your y-intercept. So now you're ready to make your line. Y equals m, negative 19, x, don't lose your x, plus b. So here's my equation of best fit. Right, use the equation to predict the bat population in 3 years. So you're like, okay, what's that? Well, let's see. Here, 7 years ago was x is 0. 6 years ago, 5 years ago, 4 years ago, 3 years ago, 2 years ago, 1 year ago, this year, but I want to know what's coming 3 years from now. So there's next year, 2 years from now, 3 years from now. I'm extending it. So in 3 years, my x value is going to be 10. So just like we did in the other problem, we're going to take out x. We're going to replace it with 10. Because if I look at the hints they gave me, this year is year 7. And they want to know in 3 years from now, 3 years later, what's the population going to be? And so we're going to plug that 10 in. And get 137. 1,000 bats, that is. Okay. So on the back, we're running the same thing. Yeah, let me help with the start of number 10, and then I will get out of the way. I'm like, why is it number 10? It should be number 3. So here I notice, okay, we got the year and we got the sales. Typically when you have a chart, X is going to be the first one. Y is going to be the second. We're also going to label our axes. So the year and the sales. And we even gotta, oh my goodness, we even gotta go ahead and put in some values on my axes. Now here, since my first chart data was in 2007, I'm just going to put the last 2 numbers of the years. You can do this how you want. I'm just trying to make it where I can still read it here. So I get each of the years going that direction. Now, the sales, I can't just copy all of these. When I'm creating my sales, I want every line to be worth the same amount. So I'm kind of looking, and I'm like, okay, so there's the low, and there's the high. If I did each line worth 10, would they fit? Let's see. So 10, 20, 30, 40, 50, 60, 70. Close enough. So if I start the bottom at 300 and make every line above it worth 10 more, this will work. But what I'm going to do is I'm going to skip every other. So like I'm not going to write 310 in here, or maybe I'll write it out here. I don't know. So like 330, 340. Hardy, why aren't you writing them on every line? I think it gets a little squished. Maybe you write small enough and neat enough that it looks good that way. But I'm going to skip every other one. What's that? No. 07, 08, 09. I'm just putting the years over here. Since they're all in the thousands, I'm like, I'll just put the last two digits so we can see the years. And again, if you want to label every single one 310 and 330 and 350, you can. That just gets a little crowded sometimes. So that's kind of how I would mess with that. Because once you've got that part, then again, you're just plotting points. So you're like, okay, 2007 we had 305,000 in sales, so right in between 0 and 10. 2008 we're at 330, so there's my 330 line. 2009 we're at 345, so in between 40 and 50 here. 10 we're at 270, right between 60 and 80. 11 we're at 395. 12 we're all the way at the top. Like I said, making this line is more of a kind of guesstimate than it is a science. So you kind of look and you're like, okay, if I start at 300, that seems a little low. What if I come out here? Then it's a little high. I mean, like I said, there's going to be no perfect answer. I mean, that's pretty good. That actually kind of touches a whole lot of lines. So you're like, okay, if that's true, what if I use, I don't know, if I use the starting line, so let's say I use this pair, and I'm looking around, I'm like, which one looks like it goes through? This one? Oh, this one? Okay. So let's say we decide that's the next best one that goes through completely. So we're going to use those two. That's not, like I said, you could have chosen some other ones. Maybe you chose that one. I don't know. Maybe you chose this one. And kind of work it that way. And then it just becomes, again, so like here's Y1 and Y2. Here's X1 and X2 and X1. Sorry about that. Y2 minus Y1. X2 minus X1. Let the calculator help us out a little bit here. So 23 that reduces to. So that's going to be my slope. Now, here's the one that gets interesting. You're like, well, wait a minute. Didn't you just get done saying in the last problem that when x is 0, that's my y-intercept? In most situations, yes, that's going to be true. But this time, it's the first point I plotted. So here, my b is going to be 305. It's basically wherever that first y point's being put. I'm still confined it on my graph, though. That was the very first spot that I was at. So then if I do that, my equation's ready for me now. Y equals, there's my slope, 23, don't lose your x, plus 305. And then to finish it off, according to your equation, in what year will the sales reach about 500? You're like, uh-oh. So how does that work? Because you're like, they're not asking me for an x value. This 500 is a y value. Okay, that's different from what we've been doing. So what do? Nothing different. I'm going to plug the 500 in for y. Because that's where the dollars are. The dollars are in the y column. And so what I'm going to have to do then is I'm going to have to solve for x. So I got 2 steps this time instead of just 1, but that's okay. What's that? Because in what year, the years are x, will the sales reach about 500,000? The number they're giving me this time is in the y column, so I got to plug it into where y is at. So I do have to pay attention to some of those things. So if I do 195 divided by 23, you're like, now wait a minute, 8.47, what's up with that? So you're like, okay, here's what's up with that. So now, so this is your 1, 2, 3, 4, 5, 6. 2013 would be 7. 2014 would be 8. And since this is 8 with a decimal, that's what we're going to go with. That one was weird. I'm glad I did that one with you. Yeah, that one was odd, to say the least. Because we're used to seeing those x numbers and things being zeros. So here's what you've got left, which is not bad. The last 3, keep that in the screen. The scatter plot's there. You're going to draw the line, come up with the equation, find the slope, and extend. It's just like the first 2 that we did. The last 2 on the page, they've already drawn you the graph. That's kind of nice. They've already told you what 2 points to use because they made a choice themselves. And then you just have to pick from the multiple choice, once you do a little calculating, what that's going to look like. So just follow your first 2 examples and you're going to have everything set for you. You're going to get some decimally answered. That's okay. That's not anything too bad. So give those last 3 a